Hi everyone, my name is Juan Carlos and I'm going to explain you 9 exercises of topic 1 and 2 of Math and Energy 2.
For the first exercise they asked us to save for the mass of the gold, and for that we use the formula. Density equals to mass over volume. Mass, we have to solve for mass. Mass equals to density times volume, and the mass of the gold is going to be equal to 1.93 times 10 to the minus 3 kilograms. So with this, that you have already the mass of the gold, you have to solve with the same mass, but now in the water. The water has gonna have the same mass. That's gonna be 1.93 per 10 times 10 to the minus 3, and the density is gonna be 1,000. And now we have to solve for volume. Here is it. Density equals to mass over density over volume. Volume is gonna be equals to mass over density. And here is the operation, and here is the result. Volume of the water is gonna be equals to 1.93 times 10 to the minus 6. Well, in the second exercise, they ask us for the pressure and the force. The pressure, I solve it by this formula. Pressure equals to density times gravity times height. Here I have density, I have height, and the gravity is 9.81. So the result was this. Then with this other formula, pressure is equals to force over area. I solve it for force. The area I already have it, that it was 1.5. So I just have to solve for force, and it was pressure times area equals to force. That was 31.290 newtons. For the third exercise, we have to use the Pascal law, because they are giving us radio 1, radio 2, and thanks to this formula, we have area 1 and area 2, and they already give us also force 2. So with Pascal law, we solve for force 1, that it's gonna be force 1 equals to force 2 over area 2 times area 1. Why? Because we solved this sending the area 1 multiplying to the other side of the equal sign. So we substitute the area 1, the force 2 over area 2 times area 1, and the result was 2040.51 newtons. For exercise 4, they are giving us radio 1 and radio 2, mass of an object that is over radio 2 over the area of radio 2. So we use this in this formula to solve the area. Area, it's going to be equal to 0.01286 meter to the square. And we have to look for the force that we can solve it by multiplying mass, that we already have it, times gravity, that is equals to force, to 2,300 times 9.81, and this is gonna be the force, 22,563 newtons. So, and once we have this, we can use this formula for solve for the pressure. Pressure is gonna be equal to force over area. So pressure is gonna be equal to 22,563 over 0.01286, and the result is gonna be pressure equals to 70,545.109 pascals. Well, this is the fifth exercise, fifth problem. In the fifth problem, they give us the density of helium, the density of the air, the volume, the weight, and they're asking us for M0. So, first of all, we have to solve for the buoyant force. The buoyant force is going to be equals to density, of course, density of air, times gravity times volume. Well, we have already, volume and density. So, it's going to be 0.9 times 9.81 times 20, and that is going to be the buoyant force, that is 176.58. So, once we have this, we use it with this formula. Buoyant force minus weight over gravity is going to be equal to m0. Then, here is it, substitute it, and the result is going to be 8.8179. Well, in the sixth problem, they are giving us the radio, that's going to be 21 meters, the mass, the air density, and the weight. Weight, we can solve it multiplying mass times gravity, that's going to be 490.5. Then, with this information, we can now know the volume. Volume, 4/3 of P times radio to the cubic. Radio to the cubic. And the result is going to be this, the volume. 3879 to 0.3869 meters cubic. Then, now we have volume. And the volume, it's going to be useful for this. Solve the buoyant force. The buoyant force is going to be equal to density times gravity times volume. So, doing the multiplication, 1.2 times 9.81 times the volume, it's going to be buoyant force equals to 45, 66, 63.96, 91. And now we have buoyant force. And with the buoyant force, we can use the formula that we used in the previous exercise. Buoyant force minus weight over gravity, that's going to be equal to the weight, the mass that we're looking for. So we substitute, and the result, it's going to be 46,500.86 kilograms. For this, that is the seventh problem. They are giving us radio, velocity, and they are asking us for quantity of flow. The quantity of flow, we need to solve it by multiplying velocity times area, but we don't have area. So we solve for area. Area is going to be P times radio to the square. It's going to be 1.2566 times 10 to the minus 3. And once we have this, we multiply in times 3, that is the velocity. And we have this, 3.769911 times 10 to the minus 3 meters square cubic over second. And in the problem says that they have liters per minute. So we have to convert this result, that is the quantity in meters cubic over second, times 1 over 0.001 times 60 over 1, if well, to convert to liters per minute, and the result is 226194.6711 liters per minute. And that's the first part. But now they are saying to us, what happened if we have to fill 20 liters? How much time does it gonna take? So we convert the liters to meter cubic, and we use the formula. Time equals to the quantity over time equals to volume over quantity, and is 0.02 over the quantity, that is this one in meters cubic, and we have time. Time is going to be equal to 5.30 seconds. Height. In the eighth exercise, they are giving us the height, that is 5 meters, the area, that in meters to the square, not millimeters to the square. Meters to the square is 0.00002 millimeters to the square. And they are asking us for the quantity of flow. The quantity of flow is going to be equals to velocity times area. But we don't have velocity, so we have to search for it. Velocity, it's going to be equals to root of 2 times gravity times height. It's going to be velocity equals to 9.9045 meters over second. Then, with this formula, now we substitute volume, area, and the result is going to be 1.9809 times 10 to the minus 4 meters cubic over second. In the 9th exercise, they are giving us height, the radius that we convert in area. The area is going to be 2.8539 times 10 to the minus 3. And with this information, we can solve for velocity. Velocity, it's going to be equal to root of 2 times gravity times height, that it's going to be 8.8588 meters over second. And then, once we know this, the velocity, we can solve for this, the quantity of flow. Quantity of flow, it's going to be equal to velocity times area. That it's going to be 0.0695776 meters cubic over second. Once we have this, we use this other formula to solve for the volume. Now it's not velocity, it's volume. The quantity of flow, we have to pass it to the other side, same as volume, and it gonna be like volume equals to quantity times time, and this is gonna be volume equals to quantity times time. It's gonna be 20.8728 meters cubic.